Vodcast follows up on Abby and Ego's previous talk about the cultural reuse of audiovisual content by introducing the research done by the CADEA project's team at Umeå University in northern Sweden. My name is Maria Eriksson, and I'm a postdoc within the project. And with me today, I've also got Pelle Snickers, who is a professor in Media and Communication Studies. So if the CADEA team in Amsterdam, again, Abby and Ego, are interested in topics like people's motivations behind video remixing and different strategies of curation within digital archives. And the CADEA group in Prague, Adela, Peter, and Vita, explore how European history and identity is reshaped through the appropriation of audiovisual content. Our team is focused on experimental ways of studying digitized audiovisual content, and more particularly in using digital methods to help identify instances of video reuse within the oceans of cultural content that is now digitally available. First of all, Pelle, why is there a need for experimental uses of digital methods in the study of video remixing and reuse?
So first of all, I think one needs to stress that during the last 15 years or so, there's been a massive amount of moving image material which has been uploaded online, foremost to YouTube, but also within prior projects in Europe, say, for example, Video Active and EU Screen, which some of us have been involved in previously. So there's a quite big corpus of moving image materials, which is now online and therefore also circulating and becoming part of the remix culture, foremost on YouTube. To study this kind of a remix culture manually is very time consuming and also more or less impossible. So at Home Lab, we started to think about ideas where we could do this kind of analysis from a more automatic perspective. The general idea was basically to do something similar to YouTube's Content ID system. So the Content ID is a software developed by Google, and it's therefore proprietary. No one else can use it, and it tracks reuse, but from a copyright infringement perspective. So it has nothing to do with research in that sense. It's about legally trying to sort of steer clear of material which are being uploaded legally or illegally. We tried to get in contact with Google and YouTube in order to get more information or perhaps access to YouTube's Content ID, but this proved to be totally impossible. No one answered our calls. So therefore at Home Lab, which is the digital humanities hub at Umeå University, we started working with developers in order to produce and develop a similar application, albeit in a smaller scale, that would sort of in a way mimic what the YouTube's Content ID system does. But this was then to be a tool that was to be able to be working for research purposes, and importantly also open source, so that other researchers and media archivists could use this tool as well. So Maria, what have we been up to in concrete detail?
Well, getting more into the technical details, we've worked closely together with Filip Alberg, Roger Mahler, Mattis Lindmark, and most recently, and perhaps primarily, Thomas Skotare, to develop this video reuse detector tool. And we call this tool is essentially kind of an assemblage or a kind of pieced together technical solution that we've built by tweaking and documenting the sort of the functionality of existing software tools and solutions, and building on existing tools and solutions to create an interface, or kind of like a toolbox for studying video reuse. So the VRD, it uses machine learning to identify visual similarities within audiovisual archives or databases. So this can involve detecting if a copy of a video reappears in its sort of fully original shape and form, or if it's reused in a modified format, like when a video's color might have been changed, or a video has been sort of interlaced with text, or the composition has been changed, and so on. So this may, for example, occur when documentary filmmakers or history programs reappropriate archival footage, but it can also occur when people make and upload video remixes on YouTube and similar platforms, for example.
This sounds a bit technical, and indeed it is, but could you say a few more words about how the tool works in more detailed form?
Yeah, so like I mentioned, the VRD uses machine learning techniques, and more specifically, so-called convolutional neural nets, or CNNs, combined with different tools for performing similarity searches to detect copies in audiovisual archives. This toolbox that we've built, it also assembles a series of tools for trimming and preparing data sets, which is of course important when you want to analyze them in these types of ways, but also sort of visualizing and analyzing matching results so that we can make sense of what this machine learning tool tells us. So put in simple terms, convolutional neural nets is an AI or technique that's used for analyzing visual imagery. And it's inspired by a model of the connectivity patterns of neurons in the visual cortex of animals like human beings, for example. These types of CNNs, they are models, they are often used in medical image analysis, image recommendation systems, but it's also often used to identify objects or people in images, for example. So this can be in order to teach self-driving cars to navigate through cities, or to identify a person in a Facebook photograph, for example. And importantly, sort of for our purposes here, CNNs can also simply be used to automatically search for and identify visual similarities. And this is what we want to use it for. And more specifically, to identify visual similarities in primarily historic databases or of moving images. So in very simple terms, one can say that a CNN is trained to observe how pixels are spatially arranged in images. They are also trained to search for unique identity markers within images. This can, for example, be areas in an image with a high contrast between neighboring pixels. And these identity markers are then used to produce successively smaller and hopefully more precise maps or interpretations of the key visual characteristic of an image or video. And these key visual characteristics can then be used to quickly search for and identify content. Kind of like a database of human fingerprints helps the police and law enforcement to identify human beings. So there are several open source convolutional neural nets available online, and we've used some of them to create a system where it's possible to match and compare one or a few, maybe 3 or 4 reference videos against a larger database, asking, for example, how, when, and where does content from these videos, say footage of the moon landing, for example, appear within a given audiovisual archive or dataset, say documentary films from the 1980s and onwards. Or we can use the tool to match and compare all videos within a database against each other. So ask sort of how, when, and where does the same video content appear within this archive, matching and comparing all videos against each other. And what this tool then, the VRD, what it essentially does is to produce an estimation of patterns of visual similarities across video files. And these estimations are represented in the form of distance metrics that kind of map or plot the visually most similar neighbors for every analyzed video. So using with the help of these distance metrics, we can speed up the process of identifying video reuse and use this tool or toolbox kind of like a guide that helps point the users towards videos that could be more interesting to study in detail. So the tool kind of says, you know, hey, if you're interested in finding video remixes or video reuse, you might want to look at these two videos in more detail because it looks like there's some overlapping content within them.
So we've been developing this VRD tool within the CADEA project now for quite some time. It has been a lot of bumps in the road, but could you say something about if the tool in a kind of beta version will be available for other researchers or for media archivists or archives in general?
Yeah, so at the moment we are finalizing the first beta version of the VRD, which will hopefully be released later this fall on VRD Notebooks, which is an interactive computing environment and sort of programming interface that allows users to run customized code through their web browsers, but also it's a tool or that's really good for guiding someone through a computational workflow. So you can have normal text explaining what the tool does and why, but also actual code running that's easy and simple to use. So we hope that these notebooks can be helpful for, as you mentioned, both archives and researchers. And in the process of putting together this first release, our goal has really been to try to make these types of machine learning technologies as transparent as possible. So this is for us, from a research perspective, not just about building a tool that works and it's useful from a research or archival perspective, but also to try to make these types of machine learning technologies and more accessible and transparent for a wider sort of public. So we really try to put some effort into describing and discussing how the different features of the VRD works and sort of highlighting both its strengths and weaknesses. Pelle, perhaps you could say something final about what we are working on right now and how we are sort of experimenting with applying the VRD.
So since the tool well, it's not really finished, but there is a beta version of it, and tests that we perform have been quite successful. So we decided to simply start writing an article where we would test the tool using historical footage. We decided on using a Swedish filmmaker or a documentarist from the 1960s. He's not that well known internationally, Gardar Salberg. But he's an interesting figure because he was the one who was responsible for Swedish film industry. That's the major film company in Sweden, their archive, and especially their newsreel archive. This was in the 1950s and 1960s. So Salberg started using the archive as a kind of commercial asset. He was compiling films put out on the market, compilation films using old newsreel from 1910 and so forth, in order to produce new films. This archive was then eventually sold to Swedish television, so it has been used quite a lot, or rather reused quite a lot within a number of TV programs. So we started out with analyzing one of Salberg's films. This is a film, Letters from Stockholm, from 1909. This was a film that he compiled in 1964. And then we were using the footage from the so-called SF archive from 1909. So we knew that our tool would find a number of matches since Salberg used the same archival material. And the article is not yet finished, but we've found some quite interesting results where the tool makes a number of matches where we thought that this was supposed to be the case, but also some intriguing examples where matches are not really the same, but they look kind of similar. The hope is to finalize this work in the forthcoming month or so, as well as trying to develop a better interface for the VRD tool. But in general, one could say that the tool is quite promising in analyzing archival reuse, and which we've then also proven with this example from the 1960s.
Great. So stay tuned.
Stay tuned. Cut.